In this video, we are going to learn how to calculate average velocity and average speed using position time graph. The question says, the graph describes the position of a particle in one dimension as a function of time. Part A of the question is asking you, in which time interval does the particle have its maximum speed and what is that speed? When you have a position time graph, with position on y-axis and time on the x-axis. And if this graph is a straight line, the speed of the graph can be found by taking the slope. And the steeper the slope, the higher is the value of speed. So in this position time graph, I need to locate the time interval which has the steepest value of slope. So if I compare each of these lines over here, I need to find which one has the highest value of slope or which line is the steepest. And if you compare them, you will notice that the line which is between the time interval -1 to 1, that means starting from 4 here to -4 over here. This is the line which has the steepest slope. And since this has the steepest slope, this will have the maximum value of speed. So I can answer question A as the time interval from -1 second to 1 second is the interval in which the particle has maximum speed, because here the position time graph has the maximum slope or the steepest slope. The question also wants me to find the value of that speed. Now you can define speed as the distance traveled over the total time. Now, when we are calculating the distance from position time graph, I need to add all the path length, the total path length traveled by the particle over the time interval. So if you notice the interval from -1 to 1 second, the total path length of the particle is 4 meter above the time axis because we are going from 4 to 0, and 4 meter below the time axis. We are going from 0 to -4. When we are calculating distance, we don't take negative value, we take only positive values. So 4 meter above the time axis and 4 meter below the time axis. That gives me my distance as 4 plus 4. And the time interval we will take as t2 minus t1, where t2 is the final time, t1 is the initial time. So you get 1 minus -1. And that gives me my value of maximum speed as 4 meter per second. This is part A. Now, part B of the question is asking me, what is the average velocity in the time interval from -5 seconds to +5 seconds? Now, we calculate velocity v as displacement over the total time. And we define displacement as change in position, which is final position minus the initial position, over the change in time, which is the final minus the initial. So my final time here is +5 seconds, and my initial time is -5 seconds. I need to find what are the position values at these two times. So let's locate them on the graph. Initial time is -5, which is over here. On time axis, -5 is here. And position of the particle at -5 is 1 meter. This is 1. So at -5, my position is 1 meter. I will call this initial position xi. Final time is +5 seconds, which is over here. This is my final time. And the position of particle at this time is -1 meter. To find the position value, go to the y-axis and locate the position. So here the position of the particle is -1 meter. I will call this as final position. Now let's substitute that in our equation. We get average velocity as final position, which is -1, minus initial position, which is 1, over final time, which is 5, minus initial time. And when you solve this, you get your answer as negative 0.20 meter per second. So when we are calculating average velocity, we take displacement over time. And when I'm finding displacement, I only concern myself with the change in position, final minus the initial. I don't care how my graph moves between these 2 points. The only thing I'm going to concern myself with is what is the initial position and what is the final position over the total time interval. Part C of the question is asking me what is the average speed in the time interval from -5 seconds to +5 seconds. Now, when we are calculating the speed, we define speed as total distance traveled over the total time. And when we are calculating the distance, you need to add length of each and every path that your particle takes when you're finding the speed. So when I take the initial and final points, like I'm starting from -5 here, this is my initial time, and we are going until +5, which is my final time. So between these time interval, I need to find the length of each and every path the particle has taken and then add all of them to find my distance. So let's take the path length for each line here. I will define this region as A. In region A, the particle position is same. It is not changing. It is a horizontal line parallel to time axis. If position is not changing, distance covered by particle in this region will be 0. Then let's call this point as P, this region as path P. In path P, the position of the particle is changing from 1 to 3. So the distance covered in going from 1 to 3 is 2 meter. Then we consider this line as path C. And in path C, the position of the particle is changing from 3 meter to 4 meter. And the distance covered in this region is 1 meter. Same thing we do for path D. The big line over here going from 4 to -4. I will call it path D. The distance covered in path D will be 8 meter because 4 meters above the time axis, 4 meter below the time axis. Or if you just subtract the values over here, you will get the total distance covered here to be 8. Again, we call this region from 1 seconds to 2 seconds as path E. Over path E, the position of the particle is not changing. And if the position does not change, the distance covered will be 0. This region over here, I will call path F. Path F, you're going from -4 to 2. When we are calculating distance, we ignore the negative sign and only take the difference in position values at my path length. So when you do 4 minus 2, you get your distance as 2. Then from 3 seconds to 4 seconds, I will call this path G. And when I go from 3 seconds to 4 seconds, I'm moving from position -2 to -1. So my path length will be 1 meter. And again from 4 seconds to 5 seconds, since my position value is not changing, distance covered will be 0. So what I did over here is I found what is the distance covered or what is the path length for each and every line over here for each and every section. And then I'm going to add all of them to find my distance. So let's add them all. We will start from path A and go until path G. At A, my distance is 0. For B, it is 2. C, it is 1. For D, 8. E, again 0. F, 2. G is 1. And then the last one is 0 divided by the total time. So total time, again, we are going from negative 5 seconds to 5 seconds. So we take the time interval 5 minus negative 5. And when you solve this, you get the speed of the particle to be equal to 1.4 meter per second. So anytime you have to calculate speed over a particular time interval, add the length of each path taken by the particle, divide by the time interval. Now part D of the question is asking me, what is the ratio of the velocity in the interval between 2 seconds to 3 seconds to the velocity in the interval between 3 seconds to 4 seconds? So I need to find velocity between two separate intervals of time, and I need to take their ratio. So let me call the velocity between 2 seconds to 3 seconds as v1 and the velocity value between 3 seconds to 4 seconds as v2. So first we will calculate v1. We know velocity is displacement over time, and displacement you get by change in position, which is final position minus initial position, over the change in time, which is t final minus t initial. So here for the first part, for t1, my initial time is 2 seconds and my final time is 3 seconds. I need to find what is the position values for this. So final time is 3 seconds and position for 3 seconds. Let's locate 3 seconds on the graph. This is 0, 1, 2, and 3. I will find what is the position at 3 seconds. So position at 3 seconds is negative 2. How do you find this position? From 3 seconds on the time axis, go to your graph, and then from the graph, go to y-axis and see what is the value on the y-axis. So x final is negative 2. This is my x final. X initial is at 2 seconds. So 2 seconds is here. Go to your graph and find the y value, which is negative 4. So negative 2 minus negative 4 divide by 3 minus 2. And when you do this, you get your V1 as 2 meter per second. Same thing we do for V2. We calculate V2 by the same method, delta x over delta t, which is final position minus initial over t final minus t initial. Now for V2, this t initial is 3 and t final is 4. So final position you will get from final value of time, which is 4 seconds here. So go to 4 seconds and look at the value of position at 4 seconds. At 4 seconds, my value of position is negative 1. Put negative 1 here minus initial position. Go to initial time, which is 3 seconds. And at 3 seconds, find what is the position value for the graph. So from 3 seconds, go down on the graph. Check the y value, which is negative 2. Divide by 4 minus 3. And when you solve this, you get the value of velocity v2 as 1 meter per second. Question wants me to find their ratio. They want me to find the ratio of velocity between 2 seconds and 3 seconds to 3 seconds and 4 seconds. So basically, I need to find what is v1 over v2. So we find v1 over v2 as value of v1 is 2, v2 is 1. So the ratio is 2 over 1. I can write v1 is to v2 equals 2 is to 1. Now let's solve part E. I will solve part E on the top here, write E here. The last part is asking us, at what time is the particle's velocity 0? Now the particle velocity will be 0 in the region where the position of the object is not changing. Whenever the position is not changing, that means displacement is 0. And if displacement is 0, velocity will also be 0. And how do you identify that from the graph? If you have a line that is parallel to time axis in position time graph, in all of those regions, velocity value will be 0. So I need to locate in my graph the lines which are parallel to time axis, which is this line over here, going from time -5 seconds to -4 seconds. So my first time interval where velocity is 0 is -5 seconds to -4 seconds. Then the second time interval where velocity is 0 is this, which is going from 1 second to 2 seconds. So the second time interval will be 1 second to 2 seconds. And then you have one more line which is parallel to time axis at the end, which is going from 4 seconds to 5 seconds. So the third one is the time interval from 4 seconds to 5 seconds. So these are the three time interval where the value of velocity is 0. And the way to find them is to find a line which is parallel to time axis. In all of those lines, the velocity value is 0. And you can take the time interval of those regions to find at what time the particle velocity is 0.